The question is A, B, C up to Y, Z are 26 metal electrodes placed at 10 meter interval, each along a line over an inhomogeneous ground for electrical resistivity tomography survey. Assuming electrodes A to Z are arranged in series and a current flow of 1 ampere between electrode A and B gives the potential difference of 500 mu volt between electrode Y and Z. Calculate the apparent resistivity for the above observation will be.
So from the question, we understood that there are 26 electrodes which are spaced at an interval of 10 meter and a current of 1 ampere is passed between A and B electrodes and it measures 500 millimeter volt across Y and Z. So we understood that A and B are current electrodes and Y and Z are potential electrodes. So we understood that A, B up to Y, Z are 26 electrodes which are spaced at an interval of 10 meter. So we understand A and B are the current electrode and Y and Z are the potential electrode. So this is the arrangement. So by this time you should have understood that this is the arrangement used in dipole-dipole configuration. Is the dipole-dipole configuration. So now let's look into the dipole-dipole configuration. We have A and B electrodes which are the current electrodes. Okay. And we have Y and Z which is the potential electrode. And there are other 22 electrodes in between them. We know it is spaced at an interval of 10 meter. 10 meter. So the equation, and so this distance can be considered as NB or something. In dipole-dipole configuration, the equation that is used to find resistivity is pi into V by I into L into L square minus A square the whole divided by A square. L is that from the midpoint of current electrodes to the midpoint of potential electrode. That is the distance between the midpoint of current electrode to the midpoint of potential electrode, which is considered as L. Okay. This is the equation. So now we have to find the distance between the midpoint of current electrode to the midpoint of potential electrode. Now the distance between A and Z. So we know that there are 26 electrodes. 26 electrodes are spaced at an interval of 10 meter. So between A and B the distance is 10 meter. Between A, B, C that is 20 meter. So between 2 electrodes the distance is 10. Between 3 electrodes the distance is 20. Likewise between 26 electrodes the distance will be 250 meter. The distance between A to Z will be 250 meter. Again, we know the distance between 2 electrodes is 10 meter and we are calculating the distance from the midpoint. Right, from the midpoint. So now we have to subtract this much distance from this total distance 250 meter we have found out to find the distance L. So the whole distance is 10, the half will be 5. Here is again the half 5. So we need to subtract 10 meter from this 250 meter to find out L. Therefore L will be 250 minus 10, that is 240 meter. And we know A equal to 10 meter. I hope you understand till this part. Now let's go to the calculation part. Here we know V equal to 500 mu meter, which is equal to 500 into 10 raised to minus 6 meter. I equal to 1 ampere. We know L equal to 250 minus 10, that will be 240 meter. A equal to 10 meter and the value of pi is 3.14. If you apply all this value, you will get the answer. Okay, so let's do 3.14 is pi into V equal to 500 into 10 raised to minus 6 divided by current is 1 ampere into L equal to 240 into 240 square minus 10 square, the whole divided by 10 square. That will be 3.14 into 500 into 10 raised to minus 6 into 240 into 240 square is 257600 minus 100 divided by 100. So if you do all these calculations, you will get around 216,660,000 into 10 raised to minus 6. So you have to shift the position of decimal to 6 place to the left. So it will become 216.660 ohm meter. So the answer is approximately 216 ohm. So the option 4 is the right answer.